Today we're going to talk about angles of elevation and depression. An angle of elevation is the angle formed by a horizontal line and a line of sight to a point above the line. So if you had a horizontal line or the ground, and then you are looking up at something above the line, then that angle that's formed right there is called an angle of elevation. Pretty clear? An angle of depression is formed by a horizontal line and a line of sight to a point below the line. So when you're talking about angle of depression, you're usually looking at something like, here's a horizontal line, and then someone looking down, this angle in here that is your angle of depression. The angle formed by a horizontal line and a line of sight looking at a point below the line. So kind of obviously elevation up, depression down. So look at page 562 down there on the bottom, example 1. And you've got the dashed lines, those are all horizontal lines. And looks like there's 3 of them. And then I'm going to make the other lines, the solid lines in those pictures, I'm going to make those blue. And then you've got some numbered angles here. Angle 3, 4, angle 5, and angle 6. Classify each angle as an angle of elevation or angle of depression. So looking at angle 3, it's formed by a horizontal and a line of sight going down, isn't it? All right, so this would be depression. That angle. Angle 4, you're horizontal and a line of sight looking at something above, right?
Elevation.
Yeah, elevation. Five is depression again. And 6 is formed by a horizontal and a line of sight looking at a point. This could be the point above the line. So another elevation. So now that you understand the definition of angle of depression and angle of elevation, the math that you're going to do in this section is the same as last week. It's going to be sine, cosine, tangent problems. But the description of the triangle that you're going to draw is going to be given to you in words. So look at example 2 up on the top of page 563. Air traffic controller. So we're going to call him an air traffic controller at an airport. Sights a plane at an angle of elevation. All right, so the air traffic controller sights a plane at an angle of elevation of 42 degrees, of 41 degrees. Can't read. The pilot reports that the plane's altitude is 4,000 feet. So the altitude is 4,000 feet. What is the horizontal distance? The horizontal distance between the plane and the airport. Between the plane and airport. So what your picture is going to look like, all right, an air traffic controller sights a plane at an angle of elevation of 41 degrees. Now here's the air traffic controller. Here's a horizontal. Here's a line of sight above the line where he sights the plane. Pilot said the plane has an altitude of 4,000 feet. So remember that an altitude, segment from a vertex to its opposite side that intersects at 90 degrees. So here's your setup. That's a bad 90-degree symbol. There's your 90-degree angle. Your angle of elevation is 41 degrees, and the plane is 4,000 feet above the ground. What is here's the key word, isn't it? The horizontal distance between the plane and the airport. So you're looking for this piece of the triangle. Here's your horizontal distance. Call it what you like. So this becomes opposite and adjacent, doesn't it? Opposite and adjacent is which ratio? Tan. So tan 41. Tangent of 41 is equal to the opposite side divided by the adjacent side. So now you can multiply both sides by x. The x's will cancel, and then divide by tan 41. And your x, or your horizontal distance, is going to be equal to 4,000 divided by 41 tan, 4,601 feet. 4,601 feet. Any questions on the picture or the math? I'm going to do example 3 on the next page, or just below that. Forest ranger in a 90-foot, let's see, a forest ranger in a 90-foot tower spots a fire. And he spots a fire at an angle of depression of 7 degrees. What is the horizontal distance between the tower and fire? And between tower and fire. Okay, so the forest ranger is in a 90-foot tower. So this could be your tower. It's 90 feet tall. Spots a fire at an angle of depression of 7 degrees. So look, if you got a fire out here somewhere, and he spots it, this is where you got to be careful. Angle of depression of 7 degrees. We said by definition, angle of depression is formed between a horizontal and a line of sight looking at a point below the line. So this angle is 7 degrees. It gets put in here a lot. That's not where it goes. That's your angle of depression. This is your triangle problem now. You're looking for the horizontal distance from the base of the tower, so from here to here. You're looking for the horizontal segment of this right triangle. Now, pay attention, please. This top red line, remember that angles of elevation and depression are formed by a horizontal line and a line of sight above or below the horizontal. This red line here is parallel to this horizontal line. They're both horizontal lines, so they're parallel to each other. So that means this line of sight is a transversal. And it makes this angle right here 7 degrees as well. So this becomes another tangent problem where you've got a 7-degree angle, you've got opposite, you're looking for adjacent. So tan 7 tangent of 7 degrees equals opposite, which is 90, over adjacent, which is the horizontal piece of this triangle. Multiply by x and divide by tan 7. The distance from the base of the tower to the fire is going to be 90 divided by 7 tan. $733 feet. Now, two things that you can do in this angle of depression problem. Since this top red horizontal is parallel to the horizontal you're trying to find, I told you that these two are alternate interior angles, aren't they? Or they're congruent. Now, if this angle is 90 degrees, it's formed by the altitude and the horizon. Well, then this angle up top is also 90 degrees. Okay? And if this angle of depression is 7 degrees of the 90, what do you got left? Good. This angle is 83 degrees. Okay? So this one and your angle of depression are complementary. The angle of depression is also congruent to this alternate interior angle. So you can use it either way you like. You could have used this 83-degree angle and opposite and adjacent, or you can use the 7-degree angle with opposite and adjacent. Okay, so you've got some options. But make sure that you put your angle of depression in here. It's formed by a horizontal and a line of sight looking down. Does anybody have any questions? Your assignment for today is going to be on page 565. How about 1 through 14? And you're going to want to check headline for homework.